Recently, I've been doing some experimenting with these. These are 3D printed notches. And the idea is that they can get embedded into your plaster to be able to align multi-part molds. So for this one, it's a 2-part mold. And the mold can be assembled and dropped together just like that, rubber band it together, and the notches provide alignment between the top and bottom parts so that we minimize the seam line inside. These notches here are meant to mimic what would be done in a traditional plaster pour for making a multi-part mold. So the idea is that you would have your form and then you would pour plaster part way, basically to the parting line. That would give you 1/2 of the mold. At that point, you could then carve into the wet plaster and create recesses, pour the rest of the plaster on top, and the plaster would then flow down into the recesses you carved. Of course, you'd want to use mold soap so that plaster doesn't stick to itself, but that creates the alignment between the top and bottom halves around your form. And of course, we need to split this because otherwise there'd be no way to get the original out or later your slip cast piece. Also, when you're doing the plaster pour, likely the surfaces aren't perfect. So in addition to the notches you intentionally create, there's probably all these little small imperfections that the plaster can flow around, and those create registrations between the top and bottom as well. However, since I'm 3D printing the pieces, we don't need to do a plaster on plaster pour. That means we don't need to worry about the plaster sticking to itself. It also means we can mix up one batch of plaster and pour both pieces simultaneously. So to do that, the mold system has a few pieces. There's this bottom ring, we have the inner mold, and the outer mold, and that gives us our pieces like that. In this video, I'm going to try something else beyond these notches. These notches worked, but they have some challenges. In particular, getting the tolerances for the 3D printed parts right is a little bit tricky. You basically need to dial it in to your printer and your filament and your print settings because the sizes of the pieces do vary just a little bit. And even when I printed a bunch of pieces on my printer at the same time, the tolerances were a little bit different. Another small problem is that there's consumables, so each mold you make, you need to use some of these pieces. If you have a 3D printer, that's not a big deal, but if you're buying 3D prints, then that's a little bit of a constraint. And the last thing is more specific to my mold system in that there is not a lot of space here, and trying to get the pieces that are embedded into the plaster in place required a few hacks. I had to lop off one side so there wouldn't be really thin plaster. That could probably be worked around. It could make the plaster thicker, but I didn't want to do that until I decided I like these. Overall, I do think this mold key system is useful. It lets you lap the faces of both plaster parts, basically sand this face and this face so they fit well together, and it does provide this horizontal alignment. The other way to do it, which is what I've been doing up until this point, is basically to have no notches at all. I can still lap the faces so they fit well together, they mate nice and flat, but the alignment comes down to me manually aligning these. And overall, I can get pretty good results. Here is a pot that I did in the last video, and there's a slight shift between these pieces. I suspect by the time you seamed it, it would basically go away, but it does take a little bit of finesse to get there. Instead of trying to mimic more traditional plaster notches, what else can we do? Well, the problem we're really trying to solve is dealing with this horizontal alignment. Basically, in these two axes, kind of X and Y, we want to make sure they're aligned. Z is taken care of by the mold face itself. So as an extreme example, we could offset the mold like this, and we'd have a step in the pot at the seam line. That might be a fun effect, but probably is not what you're going for. So we want to try and line these up. And the manual way is just feel the outside. And part of the reason this works relatively well is that we're using the shape cast molds. And in particular, we have the outer mold, which winds up giving us a nice outer surface we can use to register against. So by feeling the outside of the mold, that means the inside of the mold is likely pretty well aligned. And part of the reason that works is because of the ridges and grooves that are built into the mold pieces, in particular this bottom ring. There are a bunch of ridges for the outside mold and for the inside mold. These are basically triangles that go around in a circle. And I put them in there so that there is less chance of plaster leaking. Basically, we have to go through this zigzag pattern for the plaster to be able to escape out. But the other thing it does is because they're triangles, it also provides alignment. There's the opposite feature in the other side of the mold. And so if you were to try and slide this back and forth, the triangles help align it towards the center. Likewise for this piece. And this one, when we put it on and create the circle, it will want to try and self-center because of those triangular features. There's still some tolerance there, so it could shift around a little bit, and you have to be careful assembling the mold. But overall, that means the outside of the mold and the inside of the mold should be more or less coaxial. So if we're trying to align the pieces like this, well, what else could we do? Well, basically, we could do what I'm doing with my hands, kind of push it together. I thought about like embedding something on the sides and like squeezing down, helping that with the alignment, although we don't really need to squeeze down. That's not the problem we're solving. Rubber bands work just fine. Maybe that would be a good secondary benefit, but really what we need is this side-to-side alignment. And since this outer face here is created by this piece here, what if we just took a band of this, which is the top half of the mold, and the associated piece on the bottom half, and use that for alignment? So that's exactly what I did. I jumped into CAD and I modified the outer molds, and I came up with this ring here. So I basically took the bottom part of the upper mold and the top part of the lower mold and fused them together. There's a little bit of a round over here to give us this rounded over edge. I shrunk that down a little bit to get some clearance. I added some flanges here, and the idea is that we can put this on, and if the mold's not aligned, by basically just squeezing it, it gets pulled into position. It did take me a few iterations to get here. I think getting the tolerances right to get this to work consistently might take a little bit of doing, but I wanted to try this out and see if it worked before putting any additional effort into it. It would allow us to get around some of the problems that we have with the notches, potentially, and we can see if we like it better or not. So let's go ahead and try it out. So all we need to do is kind of loosely align the pieces. One of the things I need to make more obvious is which side's up and which side's down. The curvature here is slightly different. So if you get it upside down, it won't clamp down quite right. But the inner diameter of this ring is exactly the outer diameter of the plaster, or conversely, the inner diameter of the outer mold. I shrunk down the curved section, and so if you get it in place, it'll slide up and down just a little bit, but it should clamp down and provide nice, even pressure all the way around. So if any side's sticking out, by pulling on it, it should pull back in. I think potentially you could just do this with a strap. If it's wide enough, the strap might provide enough clamping force to move it. But I don't have any of those, and I do have a 3D printer, so I wanted to try this out. And then we can just use a binder clip like we use for everything else, and that should provide a little bit of force to keep things together. And I've been playing around with this a little bit, and I really can't get it to slide side to side. So I think it is locked in pretty well, and no fiddling required. I do think we want to add a rubber band just to help hold it together, basically keep the top and bottom pieces seated together. So this will provide the constraint in the other axis. Let me go ahead and mix up my slip. Now we get everything in place, so we should just fill it up like normal. Just like that, and we'll come back when it's time to demold and see how we did. To demold it, let's take out the rubber band. And trim the top. Now we can remove the binder clip, and this will come off. And we should be able to demold it just like before. Here's the top. And the bottom. Our lapping from last time is doing well. I don't see any residual clay. And there is our seam line. That's looking really good. Kind of feel across the edges here. And I think our alignment is good. Obviously this one's still wet, but compared to our bone dry pot where we just aligned it manually, and I can feel a little bit of a shift. We're going back to the mold keys. Yeah, this one also feels pretty well aligned. I think there's maybe a slight misalignment, but really minor. And I think our ring basically did the same. So if we compare it to the notches, we're looking very similar. I suspect the differences now are in the mold themselves. I'm going to call this a successful experiment. This bypasses several of the problems that I pointed out in my last video around using the notches and getting the tolerances dialed in. There are still some tolerances to deal with here and getting it to fit the plaster. And that was actually my first attempts. So going back to these previous iterations, the very first one, what I did is I took the face of the outer mold and just projected it inwards after joining the top and bottom together. And I have the similar attachment point. The problem is when I pinch this together, the mold actually lifted up a little bit. I don't think I can show that on camera. It's relatively subtle, but it's pulling the faces away. And what happened is this little ridge here that's in the original mold wasn't small enough. So when it pulls in, it's also acting as a wedge, prying it apart. I was like, okay, I can fix that. Let me just take the face and insert it all the way, making the ridge smaller. And the problem with this one is I also inset this face. And so while the ridge no longer is a problem, I actually had to cut off the other tab to get it to bind and close together. And that led to this last iteration. So this only has a very small little ridge in the middle, and the idea is that's just alignment, and the other faces are actually the exact outer faces of the mold. If there's any discrepancy in the outer mold, that can be taken up by this gap here to pinch together. So that tolerance is taken care of. So I think the only real trick is to make sure this ridge is small enough that it doesn't act as a wedge pushing apart these two pieces. And the other problem is this was kind of a pain to model up. It took a few iterations and it was the first time ever doing something like this. So I potentially could make that faster as well. I think the other challenge is that this also works because this is round. If we get into multi-part molds that have several pieces, we might lose that round aspect. Or going to the handles, we have the same problem. Potentially, I could make a band that goes around in a similar way, but now we have the issues with the pour spouts and blocking those. Maybe we put some holes. And since it's no longer round, that means we can't like concentrically cinch down on this. I guess the pressure would most likely be on the corners, which might be enough. And the final issue is with the way the handle outer walls are constructed. These are all flat, but that means these can actually slide around more. And there isn't that kind of self-centering aspect that the vessel molds have. As I mentioned, these are triangular shapes, so we'll tend to center those pieces. So if I wanted to use these on the handles, I'd also have to put the ridges and grooves into these parts as well. And since these are more rectilinear, I'm not too sure if the alignment piece would work as well or not. And I think it would be convenient to use kind of the same process across all of these, but I'm not too sure about the handles and how that would work. However, even with those caveats, I am liking this. This is a relatively simple piece. I think once it's designed anyways, it's easy to use. There's not a ton of filament here. I guess if you were casting multiple plaster pots at the same time, you might want to reuse this. Maybe you put it on to align it, take it off, rubber band things down. Although I think keeping it in place probably is a good idea. It also lets us slap the faces of the plaster so we can dial in that seam line. If you're modeling up your own models to pour plaster into, I think both of these are viable. There definitely are trade-offs between them. And I think I'm going to have to play around with them a little bit more to decide what I prefer. I think I'm leaning this direction. I have to tackle the modeling approach and making it more generalizable. But I think overall it is a simpler and more straightforward approach. You tell me what you think and why. Do you prefer one over the other? And if you have any other questions or comments, let me know. Thanks.